Hello everyone, myself Vansh Balani. I'm third year student at IIT Guwahati, currently pursuing BSc Honours in Data Science and AI. This is my first term project. The project code is DA377. Quick Bite is an advanced food delivery time prediction system which is built for the city of Bangalore. If you have ordered food online, you have probably noticed that the estimated time of arrival or ETA is often unreliable. Most of the food delivery platforms predict delivery time using basic formula, adding the restaurant preparation time along with delivery time, which is not accurate enough. So the urban logistic involves much more things, such as it also includes the kitchen congestion time or the security time or time which is due to the traffic delays. In Quick Bite, we tackle this with the help of machine learning and combining with the Google Maps API. So it holistically predicts and learn the click to door time, which often learn the pattern and also consider the hidden operational delays. For this project, the tools and framework I have used are Python as a core programming language, NumPy and Pandas for the structuring dataset, scikit-learn for building and training the machine learning model, joblib to serialize and save the trained model. For backend, fast API is used. For spatial calculation and API, Google Maps, geocoding API, and Google Direction API is used. And for the front end, React with TypeScript and Tailwind CSS is used for the interactive UI. Let's see how the dataset is created and how the code files look. So this is my first file. This is the data preparation pipeline and G encoding pipeline. So in this file, I have taken a few restaurants. These are the list of restaurants that I have taken along with the few customer locations. So these are the customer locations that I have taken. So what this code does is it takes each location of restaurant and the customer, it converts them into geocoding with the help of Google Map API, and finally it returns the latitude and longitude of each location so that it becomes easier for Google to track the traffic according to the latitude and longitude. And finally it dumps both the restaurant g-encoded data and customer g-encoded data to the joblib file, so it becomes easy to serialize and save for the future use. So now let's look at the another file. So this is my second file. Here I load the pre-existing joblib files which I have saved in the first part. So this load that file, and I have used a order number of 500. So this code generates 500 random orders with the random starting and ending point latitude and longitudes. So if I run this code, it looks like this. I have divided it into 50 chunks so that it becomes easy to see whether the error is coming in this place or not. So when these orders are being generated, after that I have uses one on hot encoder. In the categorical features I have used divided the things into the restaurant name, location, restaurant type and days of the week. And in numerical features I have taken preparation time, distance in kilometers, travel time in minutes, and the order hours. This is the random forest code. I have also used the grid search CV with a cross validation of 5, and the test size is kept 20%. So it is for the hyperparameter tuning purpose. So this gives the best model out of this, and after we get the best model, it is saved in the best model.joblib file. Now let's look at the quick demo. So this is the front end page. I have used render for backend deployment and Vercel for front end deployment. So here I can select the restaurant which I want. This is the destination. This is the customer location. Let's select day as Wednesday. This is the preparation time. It will be filled by the restaurant itself, but for now I've given it here. And this is the time of delivery. So let's see how it works. I have used leaflet for this interactive map. So we can see this is the restaurant and this is the path predicted by the Google Map API and Google Direction API. Here, here we can see the food prep time is 20 minutes and travel time which is taken by the driver is 36 minutes. Adding up is 56 minutes, but our food delivery estimated time is 57 minutes. The 1 minute or few minutes added are the hidden operational changes. I have included the search fee, which is calculated, for example, as the basic fare of rupees 30 and per kilometer charge is 8 rupees per kilometer. Also, some hidden charges or the peak hour charges are varied due to the traffic time. So let's select something else. As we can see, it gives the correct path, including the U-turns and all the traffic time which is included. So this is how the front end works. This when we select this, it goes to the backend. Our backend is in Fast API, so it triggers these options. And when we select this, it calls the Google Maps API, and it also uses the best model which is saved with the help of random forest and grid search CV. So now let's look at the evaluation metrics, how the model performed. So for evaluation, I have used cross validation R2, which is 93%, which shows how the model performs when we have done the cross validation across various folds. CV I have taken equals to 5. The test MAE, which is mean absolute error, is 3 minutes. This means the model average delivery time deviates by 3 minutes, which can be covered accordingly. And the test R2 is 95%, which means 95% of variance is explained by the models. So now let's see how will I cover these limitations, or how will I increase this R2 or cross validation score. Firstly, I should also include the weather data, because the traffic time is affected by the weather like rain or something. Also, to make this progress to the next version, I will use something like an open source routing machine system, which will reduce the API cost. Currently, the API is heavily used for each order. API is called. So the open source routing machine, what it does is it gives the Google Map like interface to the local machine or the our operating machine, so we can simultaneously reduce the API cost. And further, I would like to conclude by saying thank you to IIT Guwahati for giving me this opportunity. In this project, I have learned the complete machine learning to deployment pipeline. I have interacted with, I have made the front end and the back end smooth. Also, I've learned how to include the machine learning along with the full stack development. So thank you for giving me this opportunity. Thank you.